Hi, this is Jason Molesky. In this example, we'll take a look at parameters and statistics. The problem we have here is to identify the population, parameter, sample, and statistic in a variety of settings. Recall that a parameter is a value that describes a characteristic of a population. Normally, we don't know what that characteristic is because we can't measure every single element of the population. So we take a sample. A statistic is a number that describes a characteristic of a sample, and oftentimes we use that statistic to estimate the parameter of interest. Suppose the Gallup poll asked a random sample of 515 US adults whether or not they believe in ghosts, and of those respondents, suppose 160 said yes. Well, the population in this case is all US adults, and the parameter of interest would be P, the proportion of all US adults who believe in ghosts. The sample is the 515 people who were interviewed in this Gallup poll. Our statistic of interest then is P hat equals 160 over 515, or 31%, the proportion of the sample who say they believe in ghosts. Now during the winter months, the temperature outside the Starnes' cabin in Colorado can stay well below freezing for weeks at a time. To prevent the pipes from freezing, Mrs. Starnes sets the thermostat at 50 degrees Fahrenheit. She wants to know how low the temperature actually gets in the cabin. A digital thermometer records the indoor temperature at 20 randomly chosen times during a given day. And suppose the minimum reading is 38 degrees Fahrenheit. Well, the population in this case is all times during the day in question. The parameter of interest here would be the minimum temperature of the cabin that day. Since we can't track the temperature all day long, we take a look at our sample consisting of the 20 temperature readings at randomly selected times, and our statistic would be the sample minimum of 38 degrees Fahrenheit. For some additional practice with parameters and statistics, try exercise 1.